Welcome to the module Integrating Individual Elements into a Systematic Plan in Engineering. My name is Chen Qiu, and I have a background in biomedical engineering and learning sciences. Today, as the title states, we're going to look at how to integrate a series of complex individual elements such as materials, goals, technology, and marketing into a systematic plan in engineering projects. Let's begin, shall we? Have you ever wondered how engineers build functional, helpful, and effective engineering products from scratch? How does the engineer translate raw materials and brilliant ideas into a systematic building plan that directs them to a finished product? So we're going to explore the individual building elements in engineering from start to finish in this module. No matter what your background is, as you continue with the module, you'll take on the role of an engineer and participate in several engineering planning activities. In general, there are 4 and sometimes 5 big components in engineering project. To start off, the technology component is always what comes to our mind the most when we talk about engineering. Technology involves ideation, initial prototyping and design, material selection, assembly, calculation, and theories. Now, to test if the technology works, engineers will need to go through a series of laboratory experiments, and sometimes this also includes further testing in humans through clinical trials. And since different products target different audience groups, there are certain laws and regulations that govern the manufacturing, usage, and performance for the engineering process, and this is the legal component. Finally, when all of these mentioned components fall into place, the business field will take over and sell the products with product launch and business market analysis component. Notice that all of these components are like gears that are all interconnected with another. If one component changes, sometimes all of the others need to follow the change as well. If you want to learn more about the detailed process within the technology component in an engineering project, please click on the YouTube video. Now that you're familiar with how to correlate any 2 components in an engineering project, let's look at a specific biomedical engineering project for developing a neural stimulation device as an example. Using this example, I hope that you can get a grip on how to systematically plan for different components in an engineering project. From a macro point of view, the US FDA has provided a medical device development process chart, and it looks pretty similar to what we covered previously. Since developing a medical device is a very complex process, we're going to focus on the planning for the preclinical components, mainly laboratory experiments and animal testing. In the preclinical setting, there are generally 4 necessary components: in vitro experiments, animal maintenance, device prototype development, and legal regulations. Same as before, all of these components are interrelated, and according to these relationships, action items can be made. For example, the interrelationship between in vitro experiments and animals could be that we need healthy animals to perform successful in vitro experiments. So the action item for A could be care for animals for successful in vitro experiments. On the other hand, the interrelationship between in vitro experiments and device prototype could be that we need experiments that can provide validation to the device prototype. So here the action item could be to design in vitro experiments that can test the functionality of the device prototype. With the same strategy, can you fill out one action item for C through F? I have included some reference factors to take into consideration. Now that you have listed out the action items, we can translate those into a planning chart. Let's focus on the planning around animals. Notice that the arrows pointing toward animals are A, C, and F. From action item A, we can write care for animals into the planning chart. Can you fill out the spots for C and F? Here, I have provided a sample planning chart for this project. This planning chart was generated using the same techniques that we did before, from interrelationships to action items, then to a planning chart. Do you think this chart follows what you wrote in your action item list? Let's recap what we learned today. To create a systematic plan from individual components in an engineering project, first, we want to find the interrelationships between any two of the components. Then, according to these interrelationships, we can generate a list of action items. Next, we can generate a section of the final planning chart by focusing on one component and generate a plan according to the action items. Finally, we can generate a comprehensive plan covering all of the steps we need to take to make sure that all of the components are taken care of. Well, that's all we have for today. Thank you for your attention, and I hope to hear back from you on how you have benefited from this module. Adios!